Okay, students. So, till now we have discussed what all chapters you have studied in the 10th standard and what all chapters you are going to study in the 11th standard and what is the base for the 11th standard chapters. Clear? And which all chapters are going to be continued as it is from 10th standard to 11th standard. And also we have discussed what all topics are going to be very independent, which are not going to have the basis of 10th standard in 11th standard. So we all know the names of chapters and the details of the chapters. So now I am going to start the basics that you need to solve your 11th standard mathematics. Clear, students? So these basics are not going to be studied as a chapters in any 11th standard or 12th standard topics, but these basics you must know to solve the problems of 11th standard mathematics, 12th standard mathematics or chemistry, physics or any type of that science subjects. Clear? So for that reason, today I am going to start indices. Clear? So that is indices. So you all seen the expression of the form a to the power of b. We read it as a to the power of b or a exponent with b. Clear? So generally we call it as a to the power of b, where we also know that this a has to be multiplied for b times. A has to be multiplied for b times. That means a, that is a into, this is equal to a into or multiplied with a, so on to how many times? B times. This has to be multiplied for b times. Clear? Okay. Then what is the meaning of a to the power of b? You have understood. Clear? A to the power of b means a has to be multiplied for b times. Clear? This is called as exponential form. This is called as exponential form. This particular topic is going to be involved in your special functions in 11th standard. Just to keep it reminded. Clear? This topic has to be included in special type of functions in the 11th standard. Whenever you are studying the special type of functions, exponential function will be one of the special functions. There you are going to go with this type of elements or this type of expressions. Clear? Okay. So here a is base. Here a is base and b is exponent. A is base and b is exponent. Clear? Or b is also called as power. B is also called as power. Clear, students? Or this also can be called as index, or you can call it as index, no problem. Clear? This b is called as index, exponent or power. Indices means it's a plural form of index. Plural form of index. Clear? So a to the power of b means a is base, b can be called as index, exponent or power. Generally we use as power. Clear? So a to the power of b we say. We don't say a to the exponent b, or we don't say a to the index b. We generally call it as a to the power of b. Clear, students? So this is called, or this expression is called as exponential form. This expression is called as exponential form. Clear? So for this exponential form, there are some fundamental rules. Fundamental rules. As you say, addition, subtraction, multiplication and division are the four basic fundamental operations for any two real numbers. Like that, for this exponential forms, there are some fundamental rules. Let us see one by one and let us also look at the proof of those terms. Clear? So first one is a to the power of m into or multiplied with a to the power of n will be equal to a to the power of m plus n. A to the power of m plus n. Clear? So here you must understand or you must know one thing, that is a and a must be equal. That means the base has to be the same or the base has to be equal. If the base is equal, you can apply this rule or you can apply this formula, whatever you call. Clear? So a to the power of m multiplied with a to the power of n will give you a to the power of m plus n. Clear? When this is possible? Only if the base is same. Only if the base is same. Clear, students? So again, one more thing. M and n must be integers. M and n must be integers. Clear? So a and m are the base which are the same. M and n are the positive numbers or the integers. Then we can call it as a to the power of m plus n. Clear? One thing most important, the base has to be the same. Then only you can do it as a to the power of m plus n. Clear? So now let us look at proof. Clear? So as you all know, a to the power of m is equal to what? A to the power of m means what? As I have explained here, a to the power of b means a has to be multiplied for how many times? B times. On the same way, a to the power of m means a has to be multiplied for m times. A has to be multiplied for m times. Clear? So the a to the power of m means a is multiplied for m times. Next, a to the power of n means a has to be multiplied for how many times? N times. A has to be multiplied for how many times? N times. Clear? Okay. So now you know what is a to the power of m. You know what is a to the power of n. Can you tell me what is a to the power of m plus n? Now what is a to the power of m plus n? A to the power of m plus n means a has to be multiplied for m plus n times. A to the power of m plus n means a has to be multiplied for how many times? M plus n times. Clear? Okay. So you know all these three terms now. From these three terms, what I do? I will take a to the power of m plus n. That is equal to what? A is multiplied for m plus n times. A is multiplied for how many times? M plus n times. That is, first let us take, this is m times. Again, a is multiplied for how many times? Let us take, this is n times. Let us take, this is n times. Clear? So now these particular terms can be written as what? See, a to the power of m plus n. This particular terms can be written as a to the power of m. This particular terms can be written as a to the power of n. Clear? So a to the power of m plus n is going to be equal to what? A to the power of m into a to the power of n. So that is what we have studied here. A to the power of m equal into a to the power of n is equal to what? A to the power of m plus n. Clear, students? So if you don't understand or if you are not getting any information from this, please listen carefully again. Clear? First thing, what is first thing? The expression of the form. The expression of the form a to the power of b. The expression of the form a to the power of b is called exponential values or exponential forms. Clear? So now in this, a is called base, b is called either index or exponent or power. Clear? So you can call any one of these three or you can call all of three, no problem. But generally we read it as a to the power of b. Generally we read it as a to the power of b. Clear? So a to the power of b means a is multiplied for how many times? A is multiplied for b times. How many times? A is multiplied for b times. Clear? Suppose if I write a to the power of 3, a is multiplied for 3 times. A is multiplied for 3 times. If I write a to the power of 4, then a is multiplied for 4 times. So on. If I write a to the power of b, a is multiplied for b times. Clear, students? So that is the definition of exponential form. Clear? Or index. Clear? So indices is the plural form of index. Clear? Okay. So now for this exponential form, there are some fundamental rules. There are some fundamental rules. Those are, first one is a to the power of m multiplied with a to the power of n will give you a to the power of m plus n. A to the power of m multiplied with a to the power of n will give you a to the power of m plus n. Clear? So here you must understand one thing, or you must make a note of one thing, that is base has to be the same. Base has to be the same. Then only we can apply this. For example, 2 to the power of 3 multiplied with 2 to the power of 2 will be 2 to the power of 5. Clear? So here base is same. So 2 to the power of 3 into 2 to the power of 2 will be equal to how much? 2 to the power of 5. Clear, students? So if you want to prove this, or if you want to understand this rule, see here, a to the power of m means a is multiplied for how many times? M times. A to the power of n means a is multiplied for how many times? N times. Clear? A to the power of m plus n means a is multiplied for how many times? M plus n times. This a is multiplied for how many times? M plus n times. Clear? Okay. Now this a to the power of m plus n, a is multiplied for m plus n times. What I will do, I will separate m and n terms. This is m number of a elements multiplied with, this is n number of a elements. Clear? That means here a is multiplied for n times, here a is multiplied for m times. This can be written as a to the power of m. This can be written as a to the power of n. So see here, a to the power of m plus n will be equal to a to the power of m multiplied with a to the power of n. So this is what the proof of a to the power of m multiplied with a to the power of n equal to a to the power of m plus n. Clear? So now next let us go for the next fundamental rule. Clear? So next let us go for second fundamental rule, that is a to the power of m divides a to the power of n. A to the power of m is divided by a to the power of n. Clear? Understand this? A to the power of m divided by a to the power of n. Clear? So this is will be equal to a to the power of m minus n. This will be equal to a to the power of m minus n. Clear? So this is second fundamental rule. Again let us try to prove this. Clear? So a to the power of m divided by a to the power of n is nothing but what? A to the power of m divided by a to the power of n. Clear? So as you all know, a to the power of m is equal to a is multiplied for m times. A is multiplied for m times a to the power of n means a is multiplied for n times. A is multiplied for n times. Clear? So now let us go for a to the power of m divided by a to the power of n. That is a to the power of m divided by a to the power of n is equal to a multiplied for how many times? M times. Again, this is multiplied, divided by what? A is multiplied for how many times? N times. Clear? Are you getting my point? So here you must understand one thing. M must be greater than n. M must be greater than n. If m is lesser than n, there is another rule. Let us see that afterwards. Here m must be greater than n. Clear? Okay. So that means I will multiply some more terms here for some understandings. Clear? So a to the power of m means a is multiplied for m times. A to the power of n means a is multiplied for n times. Clear? As I know m is greater than n, m is greater than n, here a will be more than divided by the a's. Clear? That means m number of a's will be more than n number of a's. Clear? So for that reason, what I will do, if I go on cancelling the terms, I know that what I know, n number of elements are lesser than m number of elements. So these terms will get over. N number of elements will be cancelled from numerator as well as denominator. Here n number of elements, here n number of elements will be get cancelled. What about the remaining elements here? What about the remaining elements? This totally m number of elements. These are n number of elements. Out of this m, n are already cancelled. Please understand that from this m number of a elements, n number of elements are already cancelled. That means what? Here the remaining terms will be m minus n. The remaining terms will be what? M minus n. Are you getting my point? If you don't understand, listen again. A power m divided by a power n. A power m divided by a power n. Now I want to simplify this. A power m means a is multiplied for how many times? M times. A power n means a is multiplied for how many times? N times. Clear? So now what I will do, I will cancel a terms from the denominator and a terms from the numerator. Clear? So totally n number of elements from the denominator and the numerator will get cancelled. The remaining terms will be what? Remaining terms will be m minus n. Remaining terms will be what? M minus n. That means how can I write this? A power m divided by a power n can be written as a power m minus n. So this is your second fundamental rule. This is your second fundamental rule of indices. Clear? So first one is a to the power of m multiplied with a to the power of n will be equal to a to the power of m plus n. And the second one is a to the power of m divided by a to the power of n will be equal to a to the power of m minus n. Clear? So these are the two fundamental rules. These are the two fundamental rules of your indices. Clear? Okay. Next let us move for the third rule.